Okay guys, in the previous class I started a very important 3D robot, if you remember, 3D robot with 3 degrees of freedom. That's right, that has 3D robot that has 3 degrees of freedom. So I'm gonna replot it again because we did too many things. I'm continuing this real robot problem. So what I wanted to do at the end of the day, I wanted to drive the Jacobian Matrix of this robot. Then I go to the MATLAB, make a movie of that, and then after graduation how you have to deal with the robotic systems classically. Okay, so it was the system that we had, and in the recording, yeah, and draw. Here we go. So I said that here is first, as you have to do in any robotic system, you have to set up your reference coordinate system, and this is x naught coming out of the page. And if you look at the part 13 in the YouTube, you're going to see that, and y naught. And then I said that this is going inside the page because first of all this is theta 1, remember, is rotation around this, and I said that here is theta 2, that's right, remember this angle. So it's going inside the page because it must be parallel to the axis of the rotation or actuator. Then because the rotation is like this, I'm going to use the right hand rule. So this is y1 and x1 and y1. That's right, remember that we did in the previous class. I'm just telling you. So again, this is a rotation around for this rotation, theta 2, theta 3. So again, this is gonna be inside the page because it must be on the axis of the actuator. That's right. And based on the Dynamo-Hartenberg, I told you this is gonna be your x2, and obviously this is gonna be your y2. That's right, y2, and this is your end effector. And I'm gonna say this is, as I said in the previous class, this is z3, and this is x3. That's right. And this is so if that's the z3, this y gonna be outside of the page based on the right hand rule. So when I said here is a1 the length of this, a2 length of this, and the a3 length of this, right? So what we started, because we saw that for j we have to have j1 because the 3 degree of freedom. See that let me change the color because you're gonna kill me. It's gonna be theta 1, theta 2, theta 3. So we have 3 degree of freedom, j1, j2, and j3. And for this, I had to calculate the transformation matrix of coordinate system 1 with respect to the base. That I'm just writing here because we already did that. That's right. Sine 1 minus cosine 1, 0, 0. If you want to see the details how to derive this, go to part 13 on the YouTube. So minus cosine 1 minus sine 1 and the 0 and 0 and 0, 0 and the a1 and the 1. And I told you that I say sine theta 1, I'm summing at sine 1, cosine theta 1 as cosine 1, and forever sine theta 2, cosine 2. And then we calculated t2 respect to 0. Remember, that was, for God's sake, that was let me make it a little larger because we're gonna have minus sine 1 sine 2 means minus sine theta 1 sine theta 2 minus cosine 1 sine theta 2 cosine theta 2, 0. I derived this in part 13 of the YouTube. That's right, go and double check how I derived this step by step. Cosine 1 cosine theta 2 minus sine theta 2, 0, minus cosine theta 1 minus sine theta 1, 0, 0, and here's minus a2 sine theta 1 sine theta 2. Here was a2 cosine theta 1 sine theta 2. Here was a2 cosine theta 2 plus a1 and the 0. And then we had finally, I calculated let me write it here because it's going to be a huge one. Transformation of coordinate system 3 respect to 0. So it was a huge term, that's right. I'm going to write it here because from now on I have to simplify that. You have to minus sine 1, sine 2, sine 3 plus sine 1, cosine 2, cosine 3. Here was cosine 1 minus sine 1, sine 2, cosine 3 minus sine 1, oh, minus sine 1, sine 2, cosine 3 minus sine 1, cosine 2, sine 3. Remember, minus a3 s1 means sine, s2 c3 cosine minus a3 s1 cosine 2 s3, and here was minus a2 s1 s2. Now the next line, this is the first line, that's right. Next line was minus cosine 1 sine 2 sine 3 minus cosine 1 cosine 2 cosine 3. Here was s1, so it's minus cosine 1 s2 cosine 3 plus cosine 1 cosine 2 s3. So a3 minus a3 cosine 1 s2 cosine 3 plus a3 cosine 1 cosine 2 and sine 3. Here plus a2 cosine 1 s2. Here we go, second line. Third line is cosine 2 sine 3 plus sine 2 cosine 3 is 0. Cosine 2 cosine 3 minus sine 2 sine 3. And here is a3 cosine 2 cosine 3 minus a3 sine 2 sine 3 plus a2 cosine 2 plus a1. Here we go, and here is 0 0 0 1. Now I have to simplify this, that's right. So that's why I'm gonna take you back to what, to high school trigonometry, that's right. How is that? I'm gonna say, remember that if you have, for example, sine of theta 1 plus theta 2, this is trigonometry, gonna be sine theta 1 cosine theta 2 plus sine theta 2 and cosine theta 1. Now if you change the color here, subtract, it's gonna be also subtract, remember? Or if you say cosine of theta 1 plus minus theta 2, gonna be cosine theta 1 cosine theta 2 minus plus, gonna switch the terms, sine theta 1 sine theta 2. Or based on my notation here, I'm gonna now change it. I'm gonna say S12 means this. S12 gonna be, let me show you, okay? Look at, for example, look at this term, guys. Look at this term. I factor out S1, so what you're gonna have is cosine theta 2, cosine theta 3 minus sine theta 2, sine theta 3. So based on this, that's right. I'm gonna name it as what? I'm gonna name it as this term. I'm gonna name it as what? You tell me. I'm gonna name it as mine S1. Okay, I'm taking the S1 out, factor out. Gonna be cosine 2, 3. So now I'm gonna define it here. I said cosine 2, 3 is cosine 2, cosine 3 using this formula minus sine 2, sine 3. I just defined it. Now look at here. Now look at here. So if you factor out S1, you're gonna have sine 2 cosine 3 plus cosine 2 sine 3. So I'm gonna write it down as minus S1 2, 3 sine 2, 3. So I'm gonna define it here based on using this. So sine 2, 3 gonna be S2 cosine 3 plus S3 cosine 2. I'm just defining. Now look at this. I factor out minus A3 S1. Gonna be sine to cosine 3. That's right. Let me see. Yeah. So it's gonna be sine to cosine 3 plus cosine. It's gonna be the same. That's right. So this is gonna be minus A3 again S23. We got it. Now look at this, guys. Look at this term. If I factor out minus cosine 1, gonna be what again? Gonna be this. Look at here, guys. Because this gonna be now this sine of that. Look at here. If you factor out minus cosine 1, it's gonna be plus. Plus in the cosine gonna be minus. So I'm gonna define it cosine prime 2, 3. Gonna be cosine 2, cosine 3 plus sine 2, sine 3. Look at here. If I factor out minus cosine, gonna be sine 2, sine 3 plus. That's right, it's plus. So cosine prime means this minus here. So I'm gonna name it as. It's gonna be minus cosine 1, cosine prime 2, 3, and I defined it here, which is cosine prime. Right? And now look at this. This is gonna be, if you factor out minus cosine 1, gonna be what? Sine prime, because if you factor out cosine 1 minus cosine 1, this is gonna be, look at here, guys. I'm gonna sine prime 2, 3, gonna be, look at here, gonna be S2 cosine 3 minus cosine 2 S3. So S2 cosine 3 minus S3 cosine 2. I'm defining here. You have to use it. So I'm going to replace it as minus cosine 1 S prime 2, 3. Right? Now look at this term in the second row. If you factor out minus A3 cosine 1, gonna be S prime. That's right. So this is gonna be minus A3 cosine 1 S prime 2, 3. Next line. What is this? What is this? Look at here. This is S23, already defined. So this is S23. So what is this? Based on whatever we defined here. Here we go. Cosine 23. Right? Cosine 23. And now if you factor out A3, gonna be again A3 cosine 23. Now I can say, look at here, I have transformation metrics for frame 1 with respect to 0, transformation of 2 with respect to 0, not 3 with respect to 0. So T3 with respect to 0 after simplification gonna be this, based on whatever I defined here. Here we go. Gonna be, let me change the color. S1 cosine 23 cosine 1 minus S1 sine 23 minus A3 S1 S23 minus A2 S1 S2 minus cosine 1 cosine prime 23 S1 minus cosine 1 S prime 23 minus A3 cosine 1 S prime 23 plus A2 cosine 1 S2 S23 0 cosine 23 A3 cosine 23 plus A2 cosine 2 plus A1 0 0 0 1. Now as I go through part 13, you know that we derived, because you remember J element of Jacobian matrix for the revolute joint is Zi minus 1 cross product of O3 respect to 0 minus OI1 respect to 0 Zi minus 1. And as I taught you in the previous class, we know that zi minus 1 is rotation matrix of that frame with respect to 0 in K. What is K? K is, for God's sake, 0, 0, 1. Remember we did. So by that we said that if you say I1, I2, and I3, why? Because we need J1, J2, and J3. That's right, and J3. If you say I is 1, so Z 0. Obviously it is 0, 0, and 1. Because it is R of 0 with respect to 0. It is identity matrix in K. Here we go. So Z1, as I told you, is R1 with respect to 0 in K. And as we did the previous class, R1 with respect to 0 is this. If you multiply it by K, this is gonna be your Z1. I did previous classes, right? So it's gonna be your Z1 that you have to put here, gonna be minus cosine 1 minus sine 1 0, minus cosine 1 minus sine 1 and 0. And I derived Z2 gonna be R2 respect to 0 in K. R2 respect to 0 based on it is R2 respect to 0 because this is T2. Again gonna be the same value. Don't think that always they're gonna be same. No, this specific problem we have such a configuration. So now we have Z0 for J1, Z1 for J2, and Z2 for J3. And obviously O0 respect to 0 is 0. There's no displacement for that. O1 respect to 0 in the previous class, I said this is O1 respect to 0. Here we go. It is 0, 0, A1. Now let me go to the next page. Come on. Don't. Okay. So we got that. So O2 respect to 0, O2 respect to 0, as I taught you, this is the O2 respect to 0 because this is T2 respect to 0. O2 respect to 0. So I'm gonna write it down here. Gonna be, for God's sake, gonna be minus A2 sine 1 sine 2, A2 cosine 1 sine 2, A2 cosine 2 plus A1. And now we got all of these. We got these for different i's, these and these. Now we only need this. Obviously, this is your O3 respect to 0. Bingo, because it's T3 respect to 0. So your O3 respect to 0 gonna be minus A3 sine 1 sine 2 3 minus A2 sine 1 sine 2 minus A3 cosine 1 sine prime that we defined 2 3 plus A2 cosine 1 sine 2 A3 cosine T2 plus A2 cosine 2 plus A1. And we know O1 respect to 0 is 0. That's right. So now we can calculate everything. I can say J1, Jacobian of 1, gonna be Z0 multiplied by O3 respect to 0 minus O0 respect to 0 in Z0. So let me do this first. We know that Z0, as we have here, Z0 is 0, 0, 1. So this is gonna be 0, 0, 1 cross product of O3 respect to 0. We have it here. 03 with respect to 0. So the result is from the high school. You know that cross product is calculated as this. For God's sake, let me write it down here. I, j, k unit vectors, 0, 0, 1 this vector, and second vector gonna be minus 8, 3 sine 1 sine 2 3 minus 8, 2 sine 1 sine 2. Second is minus 8, 3 s prime 2 3 cosine 1 plus 8, 2 cosine 1 s2. Third row gonna be 8, 3 cosine 2 3 plus a2 cosine 2 plus a1. Here we go. That's right. So this is very easy. This determinant is easy. This kind of determinant of this part 0, 1 minus 8, 3 cosine 1 s prime 2 3 plus 8, 2 cosine 1 s2. Now this 8, 3 cosine 2 3 plus a2 cosine 2 plus a1 minus j again gonna be 0 and 1. Now these elements, this is determinant, this is high school things. Determinant of this, that's right. 0, 1 I said, minus 8, 3 s1 s2 3 minus a2 s1 s2, again the same term, 8, 3 cosine 2 3 plus a2 cosine 2 plus a1. Okay, plus k gonna be 0, 0, whatever it is, I don't matter, because it's gonna be 0. That's right. This gonna be 0, for God's sake. So the result of this cross product, I in this, so gonna be, it's gonna be oh, here, let me see. Let me double check this, because even a mistaken sign, positive or negative, gonna change everything. Okay. Oh my God. Let me double check my notes now. I wanna make sure. Yeah, so this is gonna be, everything is right. This is gonna be minus in this, minus a2 cosine 1 sine 2 minus a3 cosine 1 s prime 2 3 in I. That's right. Now plus a3, if you do this, sine 1 sine 2 3 plus a2 sine 1 s2 in j. So we got that, we got this. So on the other hand, a3 cosine 1 s prime, I want to double check why I wrote here as minus I want to double check, guys. Any human can make mistake. Yeah. So a prime sine 2 3 plus a2, okay, plus a3, okay. Now this is gonna be this a3 cosine 1. Alright, I'm losing my mind. Hold on, guys, I have to fix this first. Okay, guys, so this is also minus. That's right, I just double checked. So because this is minus and minus plus everything. So in minus, gonna be minus. Understand? So this is gonna be your this. So your J1, on the other hand, let me write it. We are getting closer to this 3D graph freedom system. You see that even one mistake sign gonna ruin everything, okay? So J1 gonna be based on what I write out here. Look at here, I found here. Gonna be this. Gonna be A3 cosine 1 s prime 2 3 minus a2 cosine 1 sine 2 and minus a3 sine 1 s2 3 plus a2 sine 1 sine 2, and the last part is 0, and because it's k0 and z0 is again 0 0 1 0 0 1. So bingo, we found J1. Here we go, we found it. J1 goes and sits inside here. Now we have to J2 and J3. That's right. So J2, as I said, gonna be Z1 cross product of again O3 respect to 0, O1 respect to 0 in Z1. And we established that Z1 is, for God's sake, gonna be minus cosine 1 minus sine 1 and this. So first we have to calculate this. It is very easy, guys. As O3 is this, O3 respect to 0 is this, minus A3 sine 1 S23 minus A2 sine 1 sine 2 minus A3 cosine 1 s prime 2 respect to 3 plus A2 cosine 1 cosine 2, A3 cosine 2 3 plus A2 cosine 2 minus, I'm calculating this, O1 respect to 0. Let us look at it. What is O1 respect to 0? First let me double check this. I'm human and can make mistake. Cosine 2 plus A1. That's right, plus A1. So O1 respect to 0, as I showed to you here. Here we go. 0 0 and A1. So it is 0 0 A1. So on the other hand, result is this except this A1. So now on the other hand, result of this gonna be, as I showed to you, I'm just eliminating A1. Here we go. Now I have to multiply that. Minus cosine 1 minus sine 1 and 0, cross product of this O3 respect to this, O1 respect to this. This is O3 respect to this minus O1 respect to this. Right? So it's gonna be again ijk minus cosine 1 minus sine 1 and 0. And again this term, minus a3 sine 1 s23 minus a2 sine 1 sine 2. Let me double check if I wrote the same here. Yeah, that's right. Minus a3 cosine 1 s prime 23 plus a2 cosine 1 sine 2, as we wrote here. I'm double checking. And now here you have only a3 cosine 23 plus a2 cosine 2. That's right. So let me, because I want to save the time and end to the Jacobian Matrix, I have in my notes, I want to just double check that I'm doing everything right. A human can make mistake. This is right. Minus j is cosine 0, and the k is cosine 1. That's okay. So, hold on guys, I'm gonna give you the result. I don't want to go through details of course, but I have to first double check. Bear with me. Minus sine, this is right, and this is cosine, this is right, and the k is minus cosine minus a plus minus sine in a prime, and that's right, minus s1 this, s2 this, and a3 minus cosine square plus minus a2 sine. Okay, so the result of this gonna be for the result of this gonna be this. I'm gonna write in the next page. So I double checked everything. The result gonna be z1 multiplied by O3 respect to 0 minus O1 respect to 0 gonna be minus sine 1 a3 cosine 23 plus a2 cosine 2 cosine 1 a3 cosine 23 plus a2 cosine 2 minus a3 sine 1 square sine 23 minus cosine 1 square is prime 23 minus a2 s2. Now bingo, by having that you can say j2 gonna be the same as that, minus s1 a3 cosine 23 plus a2 cosine 2 cosine 1 a3 cosine 23 plus a2 cosine 2, that's right, minus a3 sine 1 square sine 23 minus cosine 1 square s prime that we defined 23 minus a2 s2, and the z1 is this, minus cosine 1 minus sine 1 is 0. Bingo, we calculated j2. Right, now we have to replace it where? Replace it here to get the Jacobian matrix of this 3D graph number 1. Now j3. Is it recording? Yeah. Next go to the next page. Oof. Next, go to next page. Okay, so go to the next page, and this goes. Okay, so J3 gonna be what? Again, based on what I write out, gonna be Z2 cross product of O3 respect to 0, O2 respect to 0, Z2. And we found that in this page, Z2 for this specific problem, guys, is again the same. Okay, so Z2 is that minus cosine 1 minus sine 1 and 0 cross product of, and this is very easy, guys. I'm just doing here O3 respect to 2, as we calculate, is this S1 S2 3 minus A2 S1 S2 minus A3 cosine 1 S prime 2 3 plus A2 cosine 1 S2 A3 cosine 2 3 plus A2 cosine 2 plus A1 minus O2 respect to 0. We calculated how? By transformation matrix. Here we go, here we go, T2 respect to 0. So now here minus A2 S1 S2 A2 cosine 1 S2 A2 cosine 2 plus A1. Minus and plus goes, minus and minus goes, minus and minus goes. So the result of this is gonna be, for God's sake, minus A3 S1 S2 3 minus A3 cosine 1 S prime 2 3 and A3 cosine 2 3. So we have to calculate by this to have the first line. Minus A3 sine 1 S2 3 minus A3 cosine 1 S prime 2 3 A3 cosine 2 3. So if you do that and you implement Z2 here for saving your time, and let me double check it here because again human can make mistake. So J is cosine this, and this is K, and the result gonna be minus S1A cosine 2 3. This is going to be minus cosine 1 8 and cosine 2 3, and K is A3 cosine 1 square minus A3 sine 1 minus plus, and this is going to be plus C. Let's double check. So the result of your J3, the final result gonna be minus S1 A3 cosine 2 3 A3 cosine 1 cosine 2 3 A3 cosine 1 square sine prime 2 3 plus S1 square sine 2 3 minus cosine 1 minus sine 1 and 0. Bingo, this is J3. That's right, hold on, I have to do this. Okay, so now at the end of the day we now can calculate the Jacobian matrix of this 3D robot relating the joint's angular velocities to the end effector angular velocities. So this is your Jacobian matrix. Okay, gonna be based on the modifications that I had. So let me do first apply it here. So this is gonna be minus here, and this is gonna be minus here. I have a few sign mistakes. Yep, and J2 was right. Yep, and the J3 was a plus here. Okay, so your Jacobian matrix is gonna be A3 cosine 1 S prime 2 3. I'm gonna insert all of this in MATLAB, guys, all of this, because I have a lot of things to do. A3 sine 1 sine 2 3 plus A2 sine 1 sine 2 sine 1 sine 2 0 0 0 1. Let me move a little further. And the same here. I'm gonna just second line. So this was what? This was J1. That's right. Now second is minus S1 A3 cosine 2 3 plus A2 cosine 2. Let me write it based on okay, minus S1 yeah, and the second line is cosine 1 A3 cosine 2 3 plus A2 cosine 2, and the third line is minus A3 sine 1 2 square S2 3 minus cosine 1 square S prime 2 3 minus A2 S2, and the other lines are minus cosine 1 minus sine 1 and the 0. So this was what? This was J2, and the third line was minus S1 A3 cosine 2 3 cosine 1 A3 cosine 2 3 A3 cosine 1 square sine prime 2 3 plus sine 1 square sine 2 3, and the rest is minus cosine 1 minus sine 1 and the 0. And this is your J3, and the totally this matrix is J matrix. It's a Jacobian. So what can I do? This cannot relate. Bear with me, I'm not done yet theoretically. This cannot relate Vx, Vy, Vz, omega x, omega y, omega z. This cannot relate multiplied by how many links you have? How many links you have? We have 3 links. There we go. We have 3 joints, 3 degree of freedom, 3 to 1, 2 to 3. So you're gonna have here theta dot 1 angular velocities of the joints based on degree of freedom you have. That's right. Angular velocity of the joints, 2 linear velocities, and the angular velocity of the end effector. So if you remember, I was teaching you at the beginning of this course based on the forward kinematics. Forward kinematics is what? Is that you have the joints and the velocity of the joints. By using the Jacobian, you can find end effector velocities and angular velocities. Obviously, if you integrate that, you can find the end effector positions, linear positions and rotational position in space. That's right. So this is 6 by 3, 6 line 3, and this is 3 by 1. So result gonna be 6 by 1. Here we go. Bingo. This is the very efficient example that you can implement. Now, you are not done yet with this problem. That's why I told you have to learn this very carefully, because I'm gonna transfer this to MATLAB and make a simulation and make a movie and plot the parameters and too many things I'm gonna do with that. Hopefully next week.